All right, so today we are going to continue Unit 6 on relationships within triangles. And today we'll be talking about medians and centroids. To start, a median is a segment drawn from the vertex to the midpoint of the opposite side. A centroid is the point of concurrency formed by the intersection of three medians. Some people get medians and perpendicular bisectors confused, but remember, a perpendicular bisector goes through the midpoint, but it's also perpendicular, and it doesn't have to go through the vertex, right? But a median goes through the vertex and then the midpoint of the opposite side. So anyways, let's look at the centroid theorem. This states that the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint of the opposite side. So if we look at the median AE, all right, AP would be 2/3 of AE. So the point from the vertex to the centroid, that's always going to be 2/3 of the entire line, whereas this portion here would only be 1/3 of that line. To find the centroid, you would simply use this formula. So you would find the average of the x values of all the vertices, and then you would find the average of the y values of all the vertices. So obviously in a triangle there are 3 vertices, so you would find the x values, you'd add those up and then divide it by 3, and then you'd find the y values, you'd add those up, divide it by 3, and then you would have the x value and the y value of your centroid. So let's do an example. For part A, it says find the coordinates of the centroid of the triangle ABC with vertices 4, 5, 20, 25, and 36. So all you would have to do is find the average of the x values and the average of the y values. So you'll do 4 plus 20 plus 30, those are the x values, and then you divide that by 3. And then for the y values, you would do 5 plus 25 plus 6 divided by 3. So then the centroid would be 1812. All right, let's look at part B. It says there are 3 paths through a triangular park. Each path goes from the midpoint of one edge to the opposite corner. The path meets at point P. So basically, because it's going from the edge to the opposite corner, that's going to be a median. So it says for question 1, it says find PS and PC when SC is 2,100 feet. All right, so they tell us that this entire median is 2,100 feet, right? And we want to find PC, which is the portion from the vertex to the centroid, and we know that that portion from the vertex to the centroid is 2/3 of the entire segment, right? The entire median. So it's going to be 2/3 of SC, which in this case is 2,100. So then you would simply plug that into your calculator and you would get that PC is 1,400. To find PS, you would simply subtract 1,400 from 2,100. Or if you wanted to, you could do 1/3 times 2,100, since this portion here is 1/3 of the entire median. So I'm gonna just subtract them. That is easier. So I'll do 2,100 minus 1,400, and that gives me 700. All right, so for part 2, it says find TC and BC when BT is 1,000. So if BT, which is right here, is 1,000, and we know that AT is a median, and that means that T would have to be the midpoint, right? So if T is the midpoint, then that means that BT and TC are going to be congruent. So if BT is 1,000, then so is TC. To find that entire segment, BC, you would simply multiply it by 2. So BC would simply be 2,000. All right, so for question 3, it says find PA and TA when PT is 800, right? So if PT, which is right here, is 800, we know that that's 1/3 of the entire AT, right? So then, in other words, PT is equal to 1/3 of the entire AT. So if PT is 800, then I can say 800 equals 1/3 AT. And then from there, to find AT, I just multiply both sides by 3. And so then I would get that AT, or my entire side length, is 2400. So if that's 2400, and PT is, so if the whole thing is 2400 and PT is 800, to find the remaining AP, you would simply subtract 800 from 2400, so you do 2400 minus 800, and you would get 1600. So AP then is 1600. Alright, so the next thing we're going to talk about are altitudes and orthocenters. An altitude is a perpendicular segment drawn from the vertex to the opposite side. So it doesn't mean that it's going to bisect the angle, it's just going to be a perpendicular line that's drawn from the vertex to the opposite side. The orthocenter is the point of concurrency formed by the intersection of 3 altitudes. To find the orthocenter, you are going to find 2 altitudes and see where they intersect. Remember, you only need 2, because if you know 2, then you know where the third one intersects, so there's no point in doing all 3. The first thing you always want to do is to graph the triangles. That way you can see if there's any altitudes that you can easily draw and easily find the equation of just by looking at it. And if not, then you would want to find the perpendicular slopes to those 2 lines that you choose. And then instead of using the midpoint like we did for circumcenter, you would simply use the point containing that vertex, because we know that it goes through the vertex. It doesn't go through the midpoint, it does go through the vertex. So then you would use the vertex and the perpendicular slope, and then from there you would make your 2 equations, right? You would find your equations, and then you would use a system of equations to find the point of intersection. So let's try this with this example. Alright, so I went ahead and graphed my triangle. So now I'm going to choose where I want my 2 altitudes. So I'm probably going to do the altitude that goes through Y, and I'm also going to do the altitude that goes through X. The reason I chose Y is because that one is a pretty easy one to find the altitude, because if I just drew a straight line here, then I would have my altitude. Remember, the altitude goes from the vertex, and then it's going to be perpendicular to the other side. So I already know this equation. This equation here is just x equals -2. I now need to find the equation that goes through x and is perpendicular to yz. This one is not as easy to see. You can't just draw a line and hope that that's the correct equation to that line. So what you would need to do is find the slope of yz, and then find the slope that's perpendicular to that, since we know that the line is perpendicular, and then use the point x in order to plug it into point slope form. So I'll kind of walk you through this. Alright, so first I'm going to find the slope of yz by using slope formula. So it's just y2 minus y1 over x2 minus x1. So I'll do 4 minus -1 over -2 minus 3. That will end up giving me 5 over -5, which is just -1. The perpendicular slope of yz would just be the opposite reciprocal. So I would flip the -1, it would still be -1, and then I would change the sign, so then it would be +1. So the perpendicular slope of yz is 1. Now I need to figure out which point I'm going to use. Since since altitudes go through the vertex, the opposite vertex, I know that it's going to go through the point x, which is -5, -1. So I know I'm going to use the point -5, -1, and what I'll do, now that I have my slope and my point, I'm going to plug it into point slope form. So again, that's y minus y1 equals m times x minus x1. So y minus -1, which is just plus 1, equals my slope, which is 1, times x minus -5, which is just plus 5. And then I'm going to get that in slope-intercept form. So if I was to distribute the 1, it would still just be x plus 5. And then I'll subtract the 1 on both sides. I get y equals x plus 4. All right, so I have my two equations. I have this equation and I have this equation, right? So now what I'm going to do is I'm going to create a systems of equations. All right, so I have my systems of equations here. I'm going to use substitution. If you want to, you could use elimination, but I feel like substitution here is a lot easier because the x is already isolated and it says x equals -2. So I'm going to plug in -2 into my first equation to figure out what y is. So I'll do y equals, and then instead of x, I'll do -2 plus 4. And so I get that y equals 2. Now I have that y equals 2. I was already given that x equals -2, so then the point of intersection would be -2, 2. So my orthocenter here is -2, 2. Orthocenter is different than, it's very similar to circumcenter, except for circumcenter you also have to find the midpoint, because the midpoint is the point that you'll use when you plug it into point slope form, whereas in orthocenter you're going to just use the given vertex, right? So the vertex and then the perpendicular slope. The circumcenter is the midpoint and the perpendicular slope. Alright, so the next thing I want you guys to do. Alright, so on this page, I want you guys to go ahead and try this page on your own first, and then we'll go over this. But I want you to see, this is just kind of a review of all the different points of concurrency that we've done. So pause this video, try to fill out this entire chart, and then we'll go over it. Alright, so for the first example, it gives us that the property is that it's equidistant from the vertices of the triangle. If the if the point of concurrency is equidistant from the vertices of the triangle, then we're talking about circumcenter. I also included that if you draw a circle around it, then it makes P the center. Circumcenter is formed by perpendicular bisectors, so that's a segment type. And then I drew an example of that. Remember, a perpendicular bisector goes through the midpoint and it is perpendicular. And then whenever you draw this, you have your three perpendicular bisectors, and then I'm showing that that each of the vertices is equidistant to this to the point of concurrency. And I also drew a circle around it to show you that the point of concurrency is the center. Alright, so for this next one, the only thing that it gives us is angle bisector. So the point of concurrencies formed by angle bisectors is the incenter. So I drew an example of an angle bisector. It's just a line that cuts an angle in half, basically, into two equal parts. And the property here is that it's equidistant from the sides of the triangle. And if you were to draw a circle inside of it, then it makes I in the center. So I went ahead and drew that. So I have my three angle bisectors, and then you can see in the yellow that it is showing that I is the it's showing that I is equidistant from all of the sides. And remember, when we're talking about distance between points and sides, it does have to be perpendicular. And then if I draw a circle inside, then it does make I the center. Alright, so for the centroid is made up of, it's the point of concurrency made up of medians. Remember a median is whenever you draw a line from the vertex to the midpoint of the opposite side. The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So here's an example. Basically what it does is it cuts up all of the opposite sides into two because it is the median, and it does go through the vertex. Remember, from the vertex to the centroid, that's 2/3 of the entire line. And from the centroid to the midpoint, or the opposite side, that's 1/3 of the entire line. Alright, so for the orthocenter, so it says the lines containing the altitudes of a triangle are concurrent at the orthocenter. So obviously we're talking about orthocenter, and an altitude is basically a line that goes from the vertex, and it's perpendicular to the opposite side. So here's an example of how that looks like, how an orthocenter looks like within a triangle.